Hello again, everyone. Welcome to Algebra ABC Day 8 for Unit 3A on more graphing linear functions, but we're doing word problems again. And we talked on Day 7 about the very last example was creating a function, and we like the word per because that's what gets the x. So let's read our first question, see what we're talking about. Let's create an equation, then we'll graph it, then we'll answer some questions. It says, tickets to a concert cost $8 per person plus a processing fee of $4. Maybe we're going to the Canandaigua Prism concert. $8 per person plus a processing fee of $4. So I'm going to circle my two numbers. And notice I circled the per with the 8 because that tells me something. Specifically, that gets the x. So it says we can call it c equals or you can call it y equals. And then we have 8x. And it says plus a processing fee of $4. So there's our function. We're now going to plug it into our calculator. Clear out anything we did have. 8x plus 4, second graph. We got a table. Let's go back, second window, back to 0, second graph. There's our three values that we can get. Sorry about that. Let me pull that back up again. That's better. We got our three values off of our table. Specifically, 0, 4, 1, 12, 2, 20. So let's go 0, 4. If 12 is our first number and that's 3, each tick mark is 12 divided by 3, which would be 4. That's exactly where I want to start. $4 at 0. Then I go up to 12 for 1, over 2, and up to 20. Which one's 20? This would be 16, and 20 is right there. And then go over to 3 if we wanted to. 3 would be 28, which would be right there. All those points form a nice line. We're going to connect them. Try to be as exact as we can. I'm going to pull this down just a touch. That looks pretty darn good right there. All right. So now we can answer a bunch of questions. We can use our calculator. We can use the graph. How much would it cost a family of 6 to attend? Well, let's go back. What are we talking about with these numbers? X stands for the number of people, and Y, like we said, Y stands for cost. So we could write that right here. People next to the X and cost or $sign next to the Y. So 6 people, we're going to go to the x-axis and find 6. Up to my graph and over. And what do we got for 6? That looks like 4 past 48, so it looks to me like it's going to be $52. If we go to our calculator, let's check that. Down to 6. Over to 52. Beautiful. Calculator says the same as our graph. If the total was $132, not 132 people, $132. Here's the problem with our graph. There is no 132 up here. So we got to use our calculator for this one. But remember, the Y is money. So if we look for 132 in the Y column, let's see, there's 84. Let's keep going down a little bit. 100, getting close, 132, beautiful. So if it was $132, what could we say? We could have 16 people, 16 tickets. All right, well done. 1 down, 2 to go. New function. The cost of food for an honor roll dinner is $300, plus you got to pay $10 per person. Maybe the plate, the silverware, what have you, drinks. Write an equation using the function notation f of x equals the cost as a function of the number of students. Let's circle our numbers like we always do. I like to circle the per with the 10, and then we have a plus here. That pretty much tells us our function. 300 plus 10x. You got it. So now, what is the y-intercept? What is the slope? We said the slope is m, and m is the number next to the x, which in this case is 10. What is that 10? Oh yeah, that's the cost per student. Tell you what, I like to write the word per. I'm changing that. Cost per student. And if the 10 was the cost per student, that's a slope. The y-intercept must be the b, which is the number by itself, which is the other number, 300. And what is that? Cost of food. All right, well done. We got our function and we have our explanation. Let's go down and graph. Let's go to y equals on our calculator, get a table like we like to do. Y equals 300 plus 10x. Second graph, back up to the beginning. 0, 300, 1, 310. And 2, 320. Beautiful. Let's graph it. 0, 300. Whoops. 0, 300. Right here, this blue dot. 1, 310. 2, 320. I got my pattern right there. Draw my line with a nice straight edge. I've got my cheat tool. Going to go all the way off the paper like we like to do with our graphs. Beautiful. Oh, got a little bit off a line here. Let's pick it back up. There we go. All right, we graphed it. We got our equation. We got our table of values. Back to math talk. F of 10. F of 10. We've been doing this for months now. Great wall of algebra. X equals Y equals. X equals 10. 10 is the X across up to our graph and over. Looks to me like it'd be 400, and that means 10 students cost $400. And again, Y being money a lot of times. Let's go to the other one. F of X equals 1700. Great wall. X equals Y equals. The 1700's on the Y side. We can't use the graph. It's not big enough. We got to use our calculator. That's a great thing about our calculator. All right, what do we got? We got to go all the way down to 1700. So I'm going to go down and keep going down. Could take me a while. Let's see. I'm going to jump ahead. I'm going to guess. I'm going to guess something like 100. So I put 100 in the second window. Now when I go to second graph, it jumps down there. That got me closer. Still a ways off, but a lot closer. Here we go. Slow down. There it is. So X equals 140. Circle that because that's what you gave us. We gave you the 1700 and explain the meaning. And just like we did on the other one, 140 people, 140 students. Let's use the right words. At the banquet would cost $1,700. All right, sounds like our honor society or something like that. Okay, one more. Last one. It says, and this is true, maybe you guys did this in science, the frequency of a male cricket's chirp is related to the outdoor temperature. The relationship is shown as in the graph below. As the number of chirps increases, the temperature also increases. This is an increasing function. It says find the slope. Slope is m, and what have we done for m all the time? Y minus y over x minus x. And we always needed to do is pick 2 points. I'm going to pick this one and this one. That first, sorry, let me do them in different colors. The red point, x comes first, 10, y comes second, 50. The blue point, x comes first, 20, y comes second, 60. And like I just said, I'm going to label these x, y, x, y. So what are we going to do? We're going to subtract 50 minus 60 over 10 minus 20. And if you put that into your calculator, what you get is 1. And what that 1 means is, well, I know slopes mean per, so I always go x per y. So chirps per degree or temperature. Every time you hear one more chirp, it goes up 1 degree. Every time it goes up 1 degree, you'll hear one more chirp. The y-intercept, where does it cross the y-axis? Right here. That would be 40. And the answer is 40 degrees at the start, like we always say, of chirping. You don't hear chirping if it's 40 degrees or colder. You only hear chirping when it's more than 40. That's why you don't hear any crickets in the wintertime. So write a function. Well, we've got 2 numbers. We've got our y-intercept of 40 and our slope of 1. So that means f of x equals 1x plus 40. Now let's just add one more question. What if I heard 20 chirps? What temperature would it be? Well, that means we would go to either our graph. Let's see, does 20 work? 20 does work. We could go up there and get 60 degrees. Let's say on the other hand we heard 70 chirps. I don't know, that might be crazy. Well, 70, is it on our calculator, or it's on our table? It's not, so we got to go to our calculator. So let's do that real quick. Let's plug in our equation, which is 1x plus 40. 1x plus 40. I'm going to go to second graph, second window. I'm going to start at 70 because that's what I want. Second graph, 110 degrees. So maybe if it was down in Arizona, something like that. Probably not in Canandaigua. All right. Well done today, folks. That's it for our word problems. We finished just in time. Excellent work. That wraps up Unit 3A on linear functions. Now we just have our quiz and quiz corrections and work session. All right. Have a great rest of your day, guys. Thank you.